3 million years ago, beneath African skies that had never heard a human voice, something impossible began. A creature stood upright on the savannah, its hands free, its eyes scanning horizons no ape had ever contemplated before. Not just another primate, but the first whisper of what we would become, carried in bone and neurons. What if the entire story of human civilization began with a single evolutionary gamble? Inside an ancient skull, the brain was small then, barely larger than a chimpanzee's. Yet already it was learning to see the world differently. This is the story of how thinking made us human, written in stone and preserved in the curves of fossilized bone. How did 3 pounds of tissue transform a vulnerable ape into the dominant species on Earth? The answer lies buried in the sediment of East Africa, where our ancestors first walked beneath the equatorial sun. The Rift Valley stretched endlessly, a geological wound in the Earth's crust that would become the cradle of humankind. Forests were retreating, giving way to grasslands where survival demanded something more than strength or speed alone. In this crucible of change, natural selection began its most audacious experiment with the architecture of the mind. The brain consumes 20% of the body's energy, a staggering investment that must pay dividends or lead to extinction. Why would evolution favor such a costly organ? Unless the benefits outweighed the tremendous metabolic price, early hominins faced a choice written in their biology: adapt through intelligence, or vanish into the fossil record forever. Australopithecus africanus walked upright 3 million years ago, its brain case holding secrets science would not unlock for millennia. The skull was delicate, almost fragile, yet within it neurons were beginning to forge unprecedented connections and pathways. Standing upright freed the hands, and freed hands could craft tools from the stones scattered across ancient riverbeds. The first stone tools were crude, simple flakes struck from river cobbles, with deliberate force and surprising intention. But in that moment of creation, something extraordinary happened that would echo through the corridors of deep time. The brain that could imagine a tool before making it had crossed a threshold no other creature had ever approached. Abstract thought was flickering to life like the first campfire, sparking against the encroaching darkness of prehistory. 2 million years ago, Homo habilis emerged with a brain significantly larger, pushing against the limits of the possible. The expansion was not uniform but concentrated in regions governing planning, language, and the understanding of cause and effect. Can you imagine the first moment a hominid looked at a stone and saw not what it was, but what it could become? The prefrontal cortex was growing, that distinctly human region responsible for foresight, creativity, and the capacity to dream of tomorrow. Fire changed everything, transforming the night from a realm of terror into a circle of light and warmth and community. Homo erectus mastered fire 1.5 million years ago, and in doing so, rewired the very structure of existence. Cooked food released more nutrients, fueling the brain's relentless expansion across hundreds of thousands of patient generations. But fire offered more than calories. It provided time to sit together, to communicate, to build the foundations of culture. Language was emerging from grunts and gestures, evolving into something capable of conveying complex ideas across minds and time. The brain was reorganizing itself, dedicating neural real estate to Broca's area and Wernicke's area, the architecture of speech. What if language itself drove brain expansion, creating a feedback loop where communication demanded ever greater cognitive sophistication? Social groups were growing larger and more complex, requiring the ability to track relationships, alliances, and subtle hierarchies. The Machiavellian intelligence hypothesis suggests we grew smarter partly to outwit and cooperate with each other in shifting coalitions. Trust, deception, empathy, revenge. These social tools required computational power that shaped the evolution of our thinking. Minds. 500,000 years ago, brain size approached modern dimensions. Yet the revolution in thought was only beginning to unfold. Neanderthals emerged in Europe, with brains actually larger than our own, adapted to the Ice Age's brutal cold and darkness. They buried their dead with flowers, crafted sophisticated tools, and likely spoke to one another in voices lost to time. Not just why not just survival, but culture, ritual, and perhaps the first glimmerings of art and symbolic thought. Meanwhile, in Africa, Homo sapiens was evolving with a brain uniquely wired for creativity, abstraction, and relentless innovation. The human brain was becoming less about size alone and more about the intricate connectivity between specialized regions and networks. 70,000 years ago, something extraordinary happened that anthropologists call the cognitive revolution. Though its cause remains mysterious, suddenly humans were creating art, jewelry, and complex tools with a sophistication that suggested an inner world of symbols. Cave paintings emerged across continents, handprints pressed against stone walls declaring to eternity that we were here. We existed. The capacity for symbolic thought allowed humans to believe in things that existed only in the shared imagination of the tribe. Gods, nations, money. Just as these abstract concepts held power, because the human brain could agree on collective fictions together. What if the ability to believe in shared myths was a final key that unlocked civilization itself? Language had evolved beyond simple communication into a tool for transmitting knowledge across generations, defeating individual mortality through cultural memory. An elder could teach a child the location of water holes visited decades before, preserving survival information beyond any single lifetime. The brain's plasticity meant each generation could learn from the last, without waiting for genetic evolution's glacial pace of change. 40,000 years ago, humans spread across the globe, adapting to rainforests, deserts, tundra, and every environment Earth could offer. This expansion required cognitive flexibility, the ability to innovate new solutions for novel problems encountered in alien landscapes. Far from Africa, the frontal lobes gave humans the gift of delayed gratification, enabling planning for harvests, migrations, and winters yet to come. We could hold multiple possibilities in mind simultaneously, weighing outcomes that had not yet occurred against present actions and choices. The brain's mirror neurons allowed us to learn by observation, to understand the intentions of others, to build empathy and cooperation. Theory of mind emerged, that remarkable ability to recognize that other beings have thoughts, feelings, and perspectives different from our own. This cognitive leap made teaching possible, made culture cumulative, made civilization inevitable across the slow turning of the millennia. 10,000 years ago, agriculture rose independently across multiple continents, a revolution born not from necessity but from thought itself. The agricultural revolution required imagining a future where seeds planted today would yield food months hence, a sophisticated temporal projection. Surplus food created specialists, potters, priests, warriors, scribes, each role demanding its own cognitive skills and neural adaptations. Writing emerged 5,000 years ago, outsourcing memory to clay tablets and papyrus, freeing the brain for deeper contemplation and reasoning. Cities rose from stone and ambition, their complexity possible only because human brains could coordinate thousands of individuals toward common goals. Mathematics, astronomy, philosophy, these abstract disciplines emerged from brains no longer consumed by immediate survival, but free to wonder and question. Not just why not just surviving, but asking why we survive, what it means, and what mysteries lie beyond the visible horizon. The scientific revolution accelerated our understanding exponentially, as brains that evolved on savannas began to decode the fundamental laws of the universe. Today, the human brain contains 86 billion neurons, each forming thousands of synaptic connections and networks of staggering complexity and precision. We can compose symphonies, prove mathematical theorems, land rovers on Mars, and contemplate our own existence with wonder and humility. Yet we carry within our skulls the same basic architecture that served our ancestors. On the African plains 3 million years ago, The limbic system still responds to threats with ancient fear. The amygdala firing before conscious thought even registers the danger ahead. We crave sugar and fat because scarcity shaped our ancestors' metabolism in a world where calories were precious and fleeting. The brain's remarkable plasticity means it continues to rewire itself throughout life, adapting to new challenges, learning, and growing until death. Modern neuroscience reveals that thinking itself changes the physical structure of the brain, strengthening some neural pathways while pruning others away. Every skill you master, every language you learn, every memory you form literally reshapes the 3 pounds of tissue inside your skull. The evolution of the human brain is not finished. We are still adapting, still changing, still writing the story in our genes and neurons. What will we become in another million years? If we survive the challenges our own intelligence has created for the planet, climate change, nuclear weapons, artificial intelligence, these are the products of brains that evolved in a simpler, slower, more forgiving world. The same cognitive abilities that built civilization now threaten it. A paradox written in the very structure of our success and our vulnerability. Yet the brain that created these problems possesses the creativity and cooperation necessary to solve them if we choose that path forward. We are the first species in Earth's history capable of understanding our own evolution, of reading our story in fossil and gene alike. The journey from Australopithecus to Homo sapiens took 3 million years of selection, mutation, and the patient accumulation of tiny beneficial changes. Brain tissue is preserved poorly in the fossil record, yet we can read its story in the shape of ancient skulls and the tools left behind. Each fossil skull is a stone memory of someone who lived, loved, struggled, and died beneath skies that no longer look quite the same. The Tong child, discovered in South Africa, showed us that a pride walking preceded brain expansion in the human evolutionary journey. Turkana, a Homo erectus adolescent from Kenya, demonstrated that our ancestors once grew quickly and died young compared to modern humans. The Flores Island fossils revealed that multiple human species coexisted until recently, each with unique brain adaptations and survival strategies. We are not the pinnacle of evolution, but one branch among many, the sole survivors of a once diverse family tree now lost to time. Neanderthals vanished 30,000 years ago, but fragments of their DNA survive in modern human genomes, ghosts in our genetic code. Their brains were organized differently than ours, perhaps better at visual processing, perhaps less adept at complex social networks and innovation. What thoughts passed through a Neanderthal mind as they watched Homo sapiens spread across their ancestral European hunting grounds and territories? We will never know, for consciousness leaves no fossils, only the silent testimony of tools and bones and ochre stains on stone. The evolution of the human brain reminds us that intelligence is not inevitable but contingent, a product of specific circumstances and selective pressures. On another planet, under different conditions, evolution might favor entirely different solutions to the problem of survival and adaptation. We are extraordinarily lucky to exist at all, the product of countless improbable events stretching back to the first spark of life. Do you ever pause to consider that you are the temporary housing for a brain, shaped by 3 billion years of unbroken evolutionary success? Every thought you think is supported by metabolic processes older than the dinosaurs, encoded in the chemistry of cells and ancient genetic blueprints. The story of the human brain is the story of the universe waking up to contemplate itself through carbon and consciousness. We are star stuff that learn to wonder about stars, apes that learn to ask why, survivors of an impossible journey through time. The future is unwritten, but the capacity to imagine and shape it lives within the soft gray tissue behind your forehead and temples. 3 million years of evolution gave us this gift, the ability to think, to choose, to create meaning in a universe indifferent to our existence. And in that ability lies both our greatest danger an almost profound hope for whatever comes next. In the endless turning of deep time,